Okay, I'm doing an example out of the book, and I'm going to be mostly back in section 1, going over some things we didn't go over before. So there's a series they've written down, a sequence that goes like this. And so a sub 1 would be 2 to the first over 1 factorial, and that is an exclamation point. By the way, 1 factorial just means 1. 2 factorial is 2 times 1, or 2. 3 factorial is 3 times 2 times 1, or 6. 4 factorial is 4 times 3 times 2 times 1, which is 24, and so on. Oh, by the way, 0 factorial is defined to be 1. It's not 0, it's 1 to make our operating system work. All right, 2 to the first is 2, and 1 factorial is 1, so our first term is 2. Our second term in this sequence is going to be a sub 2 is going to be 2 to the second over 2 factorial. That gives me 4 over 2 times 1, which gives me 4 over 2, which gives me 2. A sub 3 is 2 to the third over 3 factorial. That gives me 8 over 3 times 2 times 1. You could reduce now or reduce at the end. 8 over 6 is 4/3. A sub 4 is 2 to the fourth over 4 factorial. That's 16 over 4, 3, 2, 1. I'm going to reduce as I go this time. 4 goes into 16 4 times. And that gives me 4 over 6, which is 2/3. So my sequence is 2, 2, 4/3, and 2/3. Just an interesting sequence. It's not arithmetic or geometric. I was just talking about how to work with factorial. Oh, by the way, this is a Easter cake made with Peeps and jelly beans. Not mine, I just found a picture of it. Okay, so next we have some problems that you'll work. 8 factorial over 2 factorial, 6 factorial. So it gives me 8, 7, 6, 5, 4, 3, 2, 1. Over 2, 1. And then 6, 5, 4, 3, 2, 1. This all cancels out, and you have this left. And then I'll reduce. 2 goes into 8 4 times, and so my answer is 28. In the future, though, I won't write it out that way. I'll probably think of it this way. 8 factorial is 8 times 7, and 6, 5, 4, 3, 2, 1 cancels out, over 2, 1, and 56 over 2 is 28. All right, next example is n factorial over n minus 1 factorial. It's kind of weird looking. So let's talk about what we would do. If we had 7 factorial, we would say 7, 6, 5, 4, 3, 2, 1. So if we have n factorial, we'll start with n, which would be like 7 or 3 or whatever. Then we have n minus 1, n minus 2, n minus 3, down forever. And n minus 1 factorial starts with that number, and then you subtract 1, which will give you n minus 2, subtract 1, n minus 3, on forever. So even though we don't know what these numbers are, we know that all of these cancel out, and they would forever, and we're just left with n. All right, to back that up, what would happen if you had 16 factorial over 15 factorial? According to this, I should just have 16. All right, this gives me 16 times 15 on down, and this gives me 15 factorial on down, 15, 14, 13. These cancel out, and I just have 16 left. All right, a word of caution here. If you have something like 8 factorial over 4 factorial, 3 factorial, and say you want to type it in your calculator, we'll talk about that in a minute. But this one's going to be 8, 7, 6, 5, 4, 3, 2, 1 cancels, over 3, 2, 1, which is 6. And so then I've got to multiply all of this together. and that would give me 280. So what I just did was 8 times 5 was 40 times 7, but it would give you 280. All right, now let's look at it on the calculator. Now on my tablet, I have a calculator that's very similar to yours. It doesn't look similar, but you see when I start pushing it will be. What if I go 8, then you go to math, and you'll go to probability. It'll probably open like this, go to probability, and on your calculator you'll choose 4. And then if you go divided by 4 math factorial, 3 math factorial, you'll get the wrong answer. It got a big, huge answer, 10,080, which there's no way that 8 factorial over 4 factorial, 3 factorial would be that big because you're dividing by all of these numbers. And so it's real important if you're going to put it in your calculator that you put this group of numbers in parentheses. And we talk about that a lot. So what if instead I had gone 8 math, you'll have to go over to, you'll probably be here and have to go to probability, divided by, put it in parentheses. So it'll, what it was doing in the first one was it divided by 4 factorial, and then it multiplied by 3 factorial because it didn't know to divide but anything but the 4. So you need to tell your calculator they're both on the bottom. By closing parentheses, I think I typed in something weird there. Let me get rid of that. That's not supposed to be there. I don't know where that came from. Okay, so anyway, sorry, 3 factorial. And we should get, whatever I had on the other screen, was it 280. So make sure if you're typing them in your calculator that you put them in parentheses. Remember, they can go into overflow. So if you had something really big like 23 factorial over 21 factorial, that would just be 23 times 22, because 21 on down cancels out, and I don't know what 23 times 22 is, but you would multiply that out and that would be your answer. Okay, so now I'm going to need to add another slide because I'm running out of slides already. Oh, sorry. Let me get rid of that. Okay. Let's get another cake. All right. So that's factorial. And then another notation that I think I've done with you, but I'm not sure, is sigma. Now, we've been having a list of numbers just like 1, 2, 3. That's a sequence. If I start to talk about a series, it's 1 plus 2 plus 3. And you actually add them together, and that's called a series. And there's a way, notation to tell me, I can use this as a Greek S, and it tells you, it's called a summation tool, and it tells you to add things up. Unfortunately, sometimes our book uses the letter I when they're not talking about imaginary. I'll usually use an N or something. But here's the first example in the book on sigma notation. All right, what this means is this tells you what number to fill in first, and this tells you what number to fill in last, and you fill in all the integers in between. So this says start with 1 as your first term. So my first term is going to be 3 times I, which you'll start as 1, and then 3 times 2, 3 times 3, 3 times 4, and you know to stop at the top number 5. And so now I don't have a series of numbers like 3, 6, 9, 12, 15. I have a series of numbers is when I'm adding it together, and you actually get a summation tool. You get a sum and you would add all of those up, and it should add up to 45. Okay, and by the way, this is an arithmetic sequence, which later on I'll teach you a formula for arithmetic. Okay, now I think I'm going to need another slide after this one, even though we're almost through. Let's see. Okay, so then Let's do the next example. The next example is a sum of 1 plus k squared, whatever variable they use. They'll tell you what k goes from. K goes from 1 to 6. And so you'll fill in 1 plus 1 squared, start at 1, plus, the next term is 1 plus 2 squared. The next one is 1 plus 3 squared. The next one is 1 plus 4 squared. And the next one is 1 plus 5 squared. And the last one is 1 plus 6 squared. All right, so this gives me 2 plus 5 plus 10 plus 17 plus 26 plus 37. All right, this is neither arithmetic or geometric. Let's see if we notice anything about this one. This is interesting. This is 3, 5, 7, 9, 11. So I'm not adding or multiplying by the same thing, but in the future, if you ever see this pattern, you'll know that it has some sort of squared in it, like k squared. So watch this. If I have 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. They skip by 3, 5, 7, 9, and 11. If you see that pattern developing, you know you have something with a squared in it later on. Okay, so let's do one more summation. This one is 1 over n factorial, and they tell you n is starting at 0, and it's stopping at 8. Okay, so I'm going to say 1 over 0 factorial, 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, 1 over 5 factorial, 1 over 6 factorial, 1 over 7 factorial, 1 over 8 factorial. All right, so notice if I went from 0 instead of 1 to 8, I have 9 terms. I filled in 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. All right, now I told you a second ago 0 factorial is defined to be 1. And so that would give me 1 over 1. 1 factorial is also 1, so this is 1. This is 1 over 2 factorial is 2 times 1, which is 2. 3 factorial is 6. 3 times 2 times 1 is 6. 4 factorial is 24. 5 factorial is 120. 6 factorial is 720, and that's as high as I know. 7 factorial I could put in my calculator, and I get 5040. And 8 factorial is 40,320. And then you would actually add them all up, and you get a sum of 2.71828, which is very, 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 very close actually to E. And so that's really interesting that that gets closer and closer to E. All right, now you can check your work on your calculator like this. So I know this doesn't look exactly like your calculator, but I'll tell you where to find this. All right, so let's clear these out. All right, so on your calculator, you'll go to the math key, which is down the left-hand side. You'll go to the first thing you come to, math, and you'll push 0. You can try it. It'll give you that summation thing. And let's see, we just did one. You can use just X. You don't have to use a K or an I. Where X, and then I'm going to move over, goes from 0, move up to 8, move over, oh, go back inside there. We'll see, I'm trying to get in that little parentheses. Why am I not in there? Let's see. Sorry. Should be able to jump in there. 1. I don't know why it's not letting me in there. I haven't actually done this before. Let me start over. You'll go math, 0. Okay. Oh, it's in there now, so I'm going to do it while it's in there. 1 divided by n, or you can use x, factorial. Go to number, factorial. All right, now I'm going to back up here and hope it lets me go in here, or I can hit it. So that's x is going from 0 to 8. And you may want to practice typing that in your calculator. And you see it gives you that 2.718 number. So you can also do summations on your calculator, but right now just to double check your work. So this may be a new symbol or an old symbol. I'm not sure if you've seen it before. But when you see sigma with things on the top and the bottom, this tells you where to start. This tells you where to stop. You would add up your terms and get your final answer. Let's see if there's any other examples I want to do. I guess I'll go on and do this one more, and then we'll go. So can't do without a picture. All right, so you also can add up an infinite sum sometimes, which sounds kind of crazy. Like suppose I had this, the sum of 3 over 10 to the n, as n goes from 1 to, let's just do 3. So right now that's going to be 3 over 10 to the first, 3 over 10 to the second, 3 over 10 to the third. This is called a partial sum, where I'm just adding up 3 terms. That's a partial sum of 3 terms. This gives me 0.3. This gives me 3 over 100, which is 0.03. This gives me 3 over 1,000, which is 0.003. And if I add that together, 0.3, 0.03, 0.003, look what I'm getting. I'm getting 0.333. Now let's go as n goes from 1 to infinity of 3 over 10 to the n. So, woo, super weird thing. I am going to be magic and add up an infinite number of terms. So it'll be 3 over 10 to the first, 3 over 10 to the second, 3 over 10 to the third, 3 over 10 to the fourth. And you can't always do that. There's going to be certain things I teach you when you can add up an infinite number, but this is just going to start being 0.3333 repeating, which adds up completely to 1/3. See what our calculator does about it. So I'm going to go to, clear this out. You'll go to Math 0, under Math 0, and let's go ahead and type it in. I have 3 over 10 to the x power, and x is going from 1 to, I don't know, I'll probably have an infinity in here. Let me see where my catalog is. Catalog. Oh. Let's see. That's not infinity. Let me get rid of that. All right, I'll tell you what I'll do for now so we can move on. I think there's a way to get infinity, but I'm just going to put in a huge number, like 1,000 terms. So that's a lot of terms. It'll go 3 over 10 to the first, 3 over 10 to the second, all the way out to 3 over 10 to the 1,000th. And do you see how I'm getting, over there on the right, my answer is 0.33333, which is the same thing as 1/3. So it actually is what we say converging. It's gravitating toward a certain number. All right, so one last thing before I give you your homework assignment on this is if I had this, the sum as n goes from 1 to infinity of 3 to the n, this would do what we call diverge. It would never end. You would have 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, 3 to the fifth, and it just keeps getting bigger and bigger and bigger. It's getting bigger and bigger and bigger. This one was getting smaller and smaller and smaller, so it converged to one number. And we'll talk more about how and when that can happen. Your homework will be on factorials and sigmas.